So I got my PhD from University d'Orléans, and I was a research visitor to the ETH Zurich. Then I got my postdoc in INVIA, EPNC, and I worked in invasive method for health. In fact, we designed a nanovector based on carbon nanotubes for drug delivery. Actually, in Tunisia, I am an associate researcher and I'm working on non-invasive method. We are using artificial intelligence for diagnostic and also for prediction of toxicity of some trial of some drugs. So in my presentation, we will talk about artificial intelligence for diagnostic, for prediction, and for drug discovery. The main rule here, the first rule that I learned in Tunisia when working with doctors, and that AI cannot and will not replace doctors, but it may dramatically change their life. How? In fact, it's by using augmented intelligence. So here we speak about augmented intelligence, which is in fact in medicine, it's to bridge computational methods with human expertise to enhance medical science and improve human health. So, as you can see here from this study by AGFA Healthcare, we can see that augmented intelligence can, in fact, be very beneficial for example, early cancer detection, which is the case here in Tunisia, as we have a lot of breast cancer. So we can say that augmented intelligence can be used for diagnostic, such as for example, COVID-19, for quantification, for drug discovery, for prediction. The concept is to mix between human intelligence and human expertise and artificial intelligence. So let's talk now about our platform on COVID-19. In fact, here in Tunisia, we have a lot of we use in fact scanner. We use a CT scan for COVID detection because in fact it was a good candidate for many reasons. It was, for example, for analysis availability. That's one for the beginning. I thought. Now we have also mainly two problems. First is the lack of radiologist experts in the interior region, and a large amount of medical image to be processed per day. For example, only for the region of Gafsa, we have to process 2,000 images per day. I'm talking about CT scan here when analyzing COVID. Also, so study shows that in the future, we recommend to monitor not only the prevalence of the virus, but also to consider the occurrence of weather situation that can lead to sudden, very explosive COVID outbreaks. So, as you know, it's not surprise that air pollution has been linked also with lung cancer. So, we developed, in fact, here an hybrid platform which consists of using IoT, using Internet of Things to collect air pollution and to correlate between air pollution and cancer propagation, or also to correlate between air pollution and COVID-19 pandemic. Here, as you can see, our experiment in the Détachement clinic. We are working with them, in fact, closely to develop our platform. They have a lot of radiologist experts, and we are improving our platform for using the vision computer to detect, in fact, nodules. Okay, let's now play just a video for a demo that we done in Ibn al-Jazzar, Kairouan, in which we use our platform to detect
Assama, donc là, nous avons l'image scanner d'un cas Covid confirmé. Puis après, on va traiter l'image par notre plateforme pour détecter les vers dépolis. Bien évidemment, avec les scoring ici. Là, on va charger l'image, comme ça. Donc c'est une plateforme orientée API, voilà, qu'on voyait ici. Ce qui se passe, c'est qu'on envoie l'image vers un cloud souverain, puis après on récupère les résultats d'une manière instantanée sur la plateforme pour afficher les scores du vers dépoli détectés.
OK. Yeah, we done some experiment here to detect ground glass lesion using fast RCNN or other methods, deep learning methods, in fact, and we got a very important result. But we are asked by doctors to, in fact, to estimate the propagation of the COVID in 3D presentation, and this is so after detect 2D the ground glass, we developed a 3D model to estimate the propagation of the COVID. So this is in fact our actual scientific cooperation with hospital here, public hospital here in Tunisia. Okay. So, as you know, in Tunisia now we have two problems. We have the lack of radiologist expert, and our equipment, such as CT scan, for example, are underutilized. So, we propose a data center in which we collect the image from the interregion. We collect CT scan, and we can in fact perform image pre-treatment, pre-processing, sorry, and then we should detect COVID or lung cancer, for example. As we are multidisciplinary team, we are in fact two medicine, two doctor, and we are three engineers working in this project. So. One of our doctor partner is in fact a specialist in cancer, in breast cancer, and we are collecting data from internal machine, and we are performing some pre-processing for image quality, and then deep learning for nodal, for example, detection. Recently, we got our NVIDIA Tesla. So we are very happy to get it. And as you can see here, we are actually implementing this the data center, and we started by the Tesla P100, and we are happy to this partnership with GSZ, that is in Tunisia, that allow us to get this NVIDIA Tesla, and we hope to in fact to optimize the use of underutilized equipment in Tunisia. In fact, we have also a cooperation in France, in cooperation with a government team of France, to deploy our platform for experiment, for prototyping that. So also, thanks to the recent cooperation with radiologists from Tunis, we are working in image segmentation by zone. I mean, by day, we can predict COVID, which it can be in which zone, the 5 first day or 5 second day. And here it's very important for then for to suggest the best treatment. Okay, so we believe that AI can be benefit for mass testing. It's low cost. In fact, also for to predict the evolution of pathology and to remote access to underutilized equipment. Okay, we have just a new project with Hospital Military in Tunisia here, in which we are trying to use artificial intelligence in another manner. Means that we are trying to detect, for example, the toxicity of nanoparticle or of nanovector for drug delivery. As you can see here in the video, I hope that it starts. Yeah, good. So when using molecular dynamics simulation to characterize the interaction between nanovector and the cell membrane, it takes a lot of computational resources. So the question here, when changing some property in the vector, in the nanovector, can we use artificial intelligence to predict the behavior, to predict the compartment, to predict the trajectory of carbon nanotubes, nanovector, or any other nanoparticle. So here it's promising a project in which we are coupling between molecular dynamics as data and artificial intelligence to predict the toxicity of nanovector and the effect of nanovector or nanoparticle on the lipid bilayer, and also to predict the trajectory just by using artificial intelligence. So I hope that I presented my idea today. So okay, you are welcome, and if you have any question, and thanks again, AMLD, for having me.
Thanks you so much, Mustapha. It's actually really impressive work, especially knowing that the financial resources in Tunisia are not as generous as like Europe and the US, but we see that the talent and creativity are there. So thank you so much. I will, as usual, go to the questions we have from the audience. So we have, I will read directly the question. So they said, very interesting, just a question about CT scans. Do you have similar CT scans, that means from the same manufacturer across the country? Experience shows images from different devices might lead to biased conclusions when applying analytics techniques. How do you handle this?
Yeah, it's a good question. In fact, CT scan, it can be, it's very sensible from one, also in the same machine, from one medicine or one technician and to other. And we are, in fact, all, if I can say it, we are really focusing in pre-processing step before artificial intelligence to give the best quality of data to perform then a good classification or segmentation. So our main work here, our main contribution is in the pre-processing state to fit or to get the best image quality.
Thank you, Mustapha, for the answer. Another question: what are the data augmentation techniques that you used?
Okay, in fact, we start, for example, by we are using segmentation. We are using filtering of image. In fact, we segment image into on two or three regions, and also filtering, Kalman filtering of image. We are using these techniques actually for pre-processing.